Good morning. I hope this video works out. I've never done one on the board like this before, so we'll see how it goes. So as you notice, I'm not in it again today, so I will see you guys all after Thanksgiving break. All right, what we want to look at today is how to add vectors. We've talked about vectors before as quantities that have magnitude and direction, or size and direction. So far when we've looked at vectors, we've looked at them as quantities that have both magnitude and direction. We can see two vectors on the page here. This one 1, 2, 3, 4 units. This one's 8 units. So this vector is twice the size as that one. All right. A couple of the things that we have on vectors is we have what we call the tail. So these are some properties of vectors. We have the tip, that's where the arrow is. So the vector always points from the tail toward the tip. Next, we can see that this vector is twice the size, as I already mentioned. So I think it mentions up here that, so the length of the arrow represents the strength of the vector. So vector B is twice as large as vector A, and it should be drawn twice the size as the other vector if it's twice the value. Adding vectors has never been much of a chore for us because all of our vectors have always been in the same plane, or not the same plane necessary, is along the same line. For example, all of our vectors were either in the x direction or in the y direction. Now we're going to start working with two-dimensional motion, so our vectors could be partly x and partly y. So we need to learn a little bit more about adding them up. So let's take a look at how we do that. First of all, when we do have vectors that are in the same direction, or in the same direction, or along the same line, when we add them, all right, it's just like any other math that you've done already. All right, if I were to add vector A to vector B, all I would have to do is put vector A, so vector A, and then add to it vector B, which is twice as long. So if this one were 20 newtons and this one were 40 newtons, the sum of the two vectors is a vector that's 60 newtons. All right, we give that sum a special name and we call it the resultant vector. The resultant vector is just the sum of two vectors, or it's the vector that is the sum of two vectors. Now if we were to subtract these vectors, again, it's just like regular arithmetic. If we were subtracting A from B, we would draw B this way, which would be 40. And then we would draw the other vector this way, which would be, I can say that that's minus 20. And so that our sum, or our resultant, would be 40 minus 20, which equals 20. I think this was newtons. All right? So there's how we subtract vectors, just like we do regular addition and subtraction. So that's what we're going to do next is we're going to actually be adding and subtracting vectors that aren't along the same line. So we have to do that a little bit differently. So that's different than just the summation, just everything added or everything subtracted, adding a few, subtracting a few. All right? So let's look at how we actually add vectors that are perpendicular to each other. The first thing we want to do is add our vectors in what we call tipped to tail. All right? So this would be vector A, this would be vector B. So here's the tail of this vector and the tip of that vector, the tail of that vector and the tip of that vector. So to add them, what we do is we place the tail of one to the tip of the other. It doesn't matter what order we go in. Either order, we end up with the same thing. So you can see here where the vectors are actually arranged tip to tail. So you can move them around on the page. They're still the same thing. As long as you haven't changed the length or changed the direction, it's still the same vector. It's like if you had a map and you had a little arrow that was 5 miles north, or an arrow that you could say represented 5 miles north. If you took that arrow, no matter where you placed it on the map, as long as it was pointing north and had the same length, it's still 5 miles north. So let's look at our vectors once we've arranged them tip to tail. So there's vector A plus B. And like we said, the vector that is the sum of two vectors, or 3 or 4, is called the resultant vector. All right, so this guy right here, all right, A plus B equals the resultant vector. I'll write that out. So some questions might just say, or ask, what is the resultant of these vectors? All right. Others might ask, what is the resultant vector? So our sum of these two vectors, you can see, no longer is just the arithmetic sum of this guy plus that guy. It's actually shorter. All right. So the actual length of this vector is that value right there. So we would have to determine that mathematically. And it's not along this line, it's actually at this angle. All right? So that's what we're going to learn to do today, is to find the actual length of the vector and the angle that it actually makes, because it's no longer going to be just in the x direction or just in the y direction. Okay, so let's continue. In a way we can look at vectors. The nice way to teach them is to think of taking a trip. All right, look at vectors as a trip. All right, so that's a nice way to visualize them. So what do? If we riding your bike through a neighborhood, a lot of times streets are like laid out north, south, east, and west. They're all perpendicular to each other. So you're confined to traveling in north, south, east, and west directions. So the sum of the vectors is the shortest distance from where you started to where you end. All right, so in order to do that, you might have to cut through some backyards and stuff like that in order to actually travel a certain vector. So let's take a look at this one. Nellie Newton. So Nellie Newton is going to travel 4 blocks to the north and then 3 blocks to the east. All right, so if Nellie Newton starts out right here and travels 4 blocks to the north, I went by 2's. This is the first vector. So there's my 4 blocks north, and then Nellie Newton's going to go 3 blocks east. 1, 2, 3. There's my third vector. So 4 blocks and 3 blocks. So what distance did Nellie travel? Well, that's a scalar, all right? So the distance that Nellie traveled was just 4 blocks plus 3 blocks equals 7 blocks. Okay? Now we want the vector. We want the resultant of actually where Nellie is relative to where she started, or we want her position. We could say the position or the displacement. All right, so that is going to be somewhat different. So the displacement is going to be, let me get another color here. The displacement of Nellie is going to be from here. It didn't work out so well. Let me try a little better. From here to there. All right? Much shorter than where Nellie actually, much shorter than the actual distance that Nellie traveled. But like I said, you'd have to go through some yards and things like that to get there. Or if you were in an airplane, you could fly above. All right, the airplane would fly just this vector rather than being confined to going up and down different streets. So let's look at how we actually find the value or the resultant of this vector. All right, what we're going to do is we're going to look at the Pythagorean theorem. So some of you may have learned this in math already. So we're just going to say displacement. We'll call this vector, this new vector, d. All right, so d squared is going to equal 4 squared plus 3 squared, which is going to be what? 16 and 9 is 25. So d is going to be the square root of 25, which is 5 blocks. So Nellie Newton's really only 5 blocks away from where she started, although she had to actually travel 7 to get there, the distance that she traveled. Now again, vectors have, along with them, a direction. So we want to measure the direction. So we're going to always measure our direction from. So lastly, let's look at how we actually calculate the angle, because if you remember, vectors have magnitude and direction. So now the direction's not just left, right, or up and down, it's on this diagonal. So we always measure our angle from the horizontal. And if you don't know your trigonometry, that's all right. We'll teach it to you. If you can't get it today, that's okay. We'll pick that up on Monday. All right. Some of you may have had this in math. Some of you may not have. So what we're going to do is I'm going to use the inverse tangent function on my calculator. So we do second tangent, TAN, that's the TAN to the -1, and then we always do rise over run. So 4 over 3, and that gives me an angle of 53 degrees. So I would say that Nellie Newton's position is 5 blocks at 53 degrees, and we'll just say northeast of where she started from. Let's do another example. If you recall, there's a lot of vectors, not just displacement vectors. There's a lot of things that are vectors. So forces, acceleration, velocities, all these values are vectors. So we can have acceleration vectors added this way, force vectors added this way, velocity vectors added this way, all types. So let's look at this next one, which is velocity vectors. So we have Jeremiah is driving his boat across the river at 12 meters per second to the east. The current in the river is 5 meters per second to the south. What is the resultant velocity? All right, remember the word resultant here means the sum. Okay, so 12 to the east, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I used up all the boxes. So 12 to the east is going to be all the way across. And then 5 to the south. So 5 to the south is 2, 4, 5 to there. 1, 2, 3, 4, 5. All right. So this is Jeremiah's resultant velocity right there. All right. So we have 12 meters per second, 5 meters per second. So our velocity is going to be v squared is going to be 12 squared plus 5 squared, all right, which that's equal to 144 plus 25. So 144 plus 25 is 169. So v squared equals 169. All right, we take the square root of both sides. And so then velocity is going to be 13 meters per second. And then we have to have an angle with that. The angle is going to be right here. So our angle is going to be inverse tangent. So theta equals tan -1 of rise, which is 5 over 12. Don't worry about the fact that the rise is negative. We'll just do this. 5 over 12. And if I calculate that out, what do we get? So we divide that out and we get 22.6 degrees. So we could say, add to this, velocity is 13 meters per second, all right, at 22.6 degrees. And what is that? That's southeast. I'll write SE for southeast. All right, there we go. So there's how we add vectors that are not in the same direction. Or I should say, here's how we add vectors that are not along the same line. Okay, so the rest of this worksheet, there's a few practice problems for you to work on. And the answers are on the bottom so you can check yourself, and have a great weekend. See you on Monday.